Hi, everyone, and welcome for coming to another Be My App webinar. We'll be starting shortly. Once again, very shortly. Okay, ladies and gentlemen, welcome for coming another Be My App webinar. My name is Fernando. It is a pleasure having all of you again. For those who are going to be joining us after, as always, you can just rewatch this video after. If you have any questions, just feel free to let us know. In today's episode, we actually have revolving around backend. So with that, we have Joel Lord. He's going to be speaking about Socket.io and Node. And without further hesitation, I'll let the man speak for himself. So Joel, you have the platform.
Thank you, Fernando. Hello everyone. Welcome to this webinar about Socket.io and WebSockets in general, essentially. So I'll take a few minutes to talk a little bit about me, what I do, and then I'll jump right into the subject, which are WebSockets. And I'll take about maybe half an hour just to go through a little bit of theory, and then we'll look at some examples together. So hopefully you'll be able to participate in those live demos because it's real-time information. So you will be able to participate in those, and we'll see how that works. So let's get started. So a little bit about myself quickly. So I work for Spiria. We're a custom software company. We are based in Montreal. The headquarters are in Montreal. I am located in the Ottawa office. And this is what our office looks like. And I've learned today that we are an official Pokestop. I have no clue what that really means, but apparently that's the case. So I thought it was a very interesting picture. So this is what our office looks like. So like I said, we do custom software development, and we play with a wide range of technologies. And that's a very interesting thing that we can do. So we can build applications, whether it's in JavaScript, which is my main language, but we also do mobile native development. We do desktop applications and so on. Like I said, I'm mostly a JavaScript junkie. Whenever I can do something in JavaScript, I usually try to use JavaScript to do it, which is just about anything now. I'm a bit of a tinkerer. I'm involved in the maker movement in the Ottawa area, so I do different things there. And I'm a technology enthusiast, so I really like to read about new technology and try to share those information when I get them. So WebSockets, what are they? So the first time I've encountered a WebSocket was when I was working with Trello. I think most people are familiar with this tool. So I was using Trello, and all of a sudden, one of my colleagues updated one of their cards, and I noticed that it actually changed the card on my screen live as I was playing with it. So I did whatever a programmer would do. So I opened up the source code, opened up my network window, and I was quite surprised to see that there was no real traffic going on, or nothing that I could see in my network window. So I dug up into the source code just to see what I could find there, and that's when I first encountered Socket.io, which is pretty much what actually brought me to the Node.js world as well. So I started exploring, and I started reading about those WebSockets and how I could use them in my different projects. And this is what I'd like to share with you today. So in a nutshell, WebSocket is a protocol providing full duplex communication channels over a single TCP connection. And it was standardized in 2011 as part of an RFC, and it's now being standardized by the W3C. But what does this really mean? So essentially what that means is that WebSockets are a way to basically create a tunnel between a client and a server, and then you can send information in any direction. So whether it's your client sending information to your server, like we're used to do in the web world and the world of REST interactions, but you can actually also send data from the server to the client, which is not something that we're used to. But when you're trying to do real-time application, or when you need to update some things in real time, it's a very, very valuable asset that you can use. So how do we typically simulate real time in our applications? Up to now, most of the people use, or actually in a typical application, you would just use an HTTP request. So if your user is doing something on a web page, clicks on a button, you need to display information, your client sends information to the server, and the server sends a response back. And then you treat that response, you do something with it. When there's another interaction at another point in time, say the user scrolled past a certain limit, the client will actually request more information from the server. Hey server, can I have that piece of data? Server sends back information. So that's how we typically do applications with a REST server. Now, if you want to display something in real time, say you have a dashboard and you want to update the data on your graphs in real time as things are happening, if you use more or less the same principles as we've seen in regular applications, you'll do polling. So what you'll do is that you'll ask the server for more information. So you just basically keep on pinging the server, hey server, is there anything new? And the server just, no. Now, is there anything new? No, and so on. It's what I call the kids in the car scenario. So it's a little bit like having your children in your car if you have small children, and they'll just keep on asking you, are we there yet? No. Are we there yet? No. Are we there yet? And they just keep on asking until there's actually something to update. And are we there yet? Yes, we're there. So you can just give the response back to the client. So that's one way to do it, but obviously it consumes a lot of bandwidth. I mean, you are requesting a lot of, you are doing a lot of requests to the server, and most of the time they will just return either the same answer that you already had, or simply nothing. So another way to do it is using long polling. So in this scenario, what you can do is that you tell your client to ask the server for data once, and the server will keep that connection until it actually has something to respond to you. So that's a nice way to do, but you also have to implement some sort of way so that whenever the connection times out, you need to recreate this connection, and you still have all those ongoing handshakes every time that you want to do a connection like here. So those worked. It's a nice fallback situation, but what we want really is a way to have a communication that is full duplex, a communication that be completely bidirectional, where the server can actually just decide to send data to the client if it actually has some data that changed. So as you can see here with a WebSocket, with WebSocket, I have some data that comes in from my server and is just pushed to the client. And if the client wants to send data, he can just push it, and the server can react to that data, sending an answer back and send something else. At the same time, the other client can. So all the communications are in both ways, and they can happen basically simultaneously. So you might have read about server-side events as well. So how do they differ from WebSockets? Well, the goal of this presentation is not to go into details on server-side events. There's a lot of pros and cons to server-side events. But in the case that we are interested in, the main difference is that server-side events, as described in the name, obviously, are only triggered by the server. So it only sends data from the server to the clients, but the client cannot send data using server-side events. You would need to use HTTP requests at the same time in order to send data to the server. So should you use them? Well, obviously, as you might have guessed, I really like WebSockets. I mean, we definitely should use them, in my opinion, wherever we can. In this time and age, users are used to have almost immediate access to information. So you need to find a way to send the information to the user rather than actually asking or having the user to request that information. You need a way to push that information as soon as possible, and WebSockets are a great way to do that. It delivers a much better user experience, and by adding this value to your products, you will have a better return, better user response, and obviously better user response will probably lead to more revenue. So it's something that you definitely should look into, at least if it makes sense to your solution, and see how you could use it. So let's look at some of the pros. Like I said, it's bidirectional data transfer. I cannot put enough emphasis on that. It's a way to push the data to the clients, which makes it much faster to get the data on the screens. Also, the fact that it establishes a tunnel and keeps that connection alive makes it much faster to send data from the server to the client or from the client to the server. So that communication is fast and uses a very low bandwidth, so you don't have to bother with all the handshakes. Well, the browser takes care of that for you, but still you reduce the time and bandwidth with useless data that you don't have to send anymore because the tunnel is already established. Another nice thing about it is that it detects connection and disconnection, so you can see who's online, for example, or who's not online. So the cons, well, I don't really want to give you any cons because I really want you to use WebSockets as much as you can. But obviously, there still are some. So you do lose the caching capabilities, which are built in your XHR requests. So when using typical HTTP, there will be some caching. The browser keeps the responses, so you kind of lose that. On the other hand, most of the data that will be transferred using WebSocket is probably something that you don't want cached anyways. You'll most likely need to do some architectural changes in the application as well. Because you're now listening for data that comes from the server, you need to build a event-based application rather than having an application that requests for data and then reacts when the data comes in. So it's a little bit of a change in the way that you build your application, but if you do it right from the start, it's much easier to implement. So some of the real-world cases for WebSockets, there's a lot of different applications that use them, although I would argue that there's not enough. But some examples that we can see that you've probably been using on a day-to-day basis without even noticing it. But real-time synchronization of data between a group of users, Trello is one such example, but we've built different applications here, stuff like ensuring that all the actors in a single process all have the same information at the same time. So you want the data to be synchronized. So you want, as soon as one user changes something, it gets pushed to the other users that are connected there. So that's one case. Things like live feeds, for example, where you want to keep a stream of data on a web page or on a web application. Things like Twitter streams. And I will show you an example of a Twitter stream in a few minutes. Long server processes and a way to provide an ETA to users. So I built an application not so long ago where we had to aggregate a lot of data from a lot of very big files. So we're talking about terabytes of data that we had to crawl into and then provide an update to the users. So they had this dashboard and they could launch this process to regenerate all of that data. And that would take a very long time. But we knew how many files we had. We knew the total size of the files and so on. So it was easy for us to, when we launched that process, to go see the total number of files. And then based on that, we would push information to the customers, to the clients that were connected, as it would crawl through the files. So after it did the first file out of 10, it would push a notification to the client saying, okay, we're 10% done. And then it would start with the second file and so on. So it's a nice way to provide an ATA to the users based on what is actually going on your server. If you've played multiplayer HTML5 games, obviously, most likely it's using WebSockets as well, so that the information is synchronized between all the clients that are connected, and chat clients, things like Slack, which almost everybody is using nowadays, especially in our sphere. So all the data that, well, obviously is synced between all the clients, so whenever you're sending it or a chat line to somebody, as well as the presence data, being able to see who's online and who's not, and that type of thing, they all come from WebSockets. And I will also show you a quick example of that. Chat applications are essentially the hello world of WebSockets or any real-time communication, so we'll go through an example. So how do you use it? Well, it's fairly easy. With most modern browsers, they are built in. And by modern browsers, I mean everything which is not IE9, but everything up is working. So essentially, you just create a new connection by instantiating a new WebSocket, and you give it the URL. It's as simple as that. Once you have your connection, you have a few events which are on open, which means that your connection is established. You have a on message event, which will be triggered whenever the server pushes some data. And you have an on close, so whenever the connection gets closed, whether it's because of a server failure or because the customer actually decided to disconnect it. So those are the main events. So how do you send data to the server now? Fairly easy. You just use the send method on your connection. So you can send strings by using a simple string. You can send array buffers as well. So if you want to send an image, for example, you can send blobs. So if you want to send a file to the server, you can use this. And how about JSON objects? Well, unfortunately, you cannot send JSON objects, and I said you cannot send them. But there's a very easy workaround where you can just stringify your JSON objects and then send that string to the server. So it's still fairly easy to do. You do have to be careful, though. If you're using that, you need to be sure that you are parsing into a JSON object at the other end, so on the server. But you also need to make sure that you are not trying to parse a string, so you have to manage your errors there, or to catch some errors. So if you want to get started with WebSockets, there's a good number of alternatives that are available. There's cloud solutions that are available. I've seen them in the past. They work really well. If you don't want to be bothered with all the architecture that is needed or the infrastructure that is needed, they also include a lot of different things that you can get out of that solution. Things like security, history of messages, things like that are built into those cloud solutions. Obviously, they cost money. And depending on the amount of traffic that you have in your application, you might want to consider having your own implementation that runs on your own server. So in order to do that, there are various frameworks or libraries that are available. If you're into PHP, Ratchet is a solution that I've used in the past, and it works really, really well. If you are into Java, Jetty is an implementation of WebSocket for Java. I have never used it in the past, so unfortunately I cannot provide you with information, but I know that it's there. And because we're talking about Node.js right now, and because JavaScript is my preferred language, I've used Socket.io mostly. And Socket.io is my favorite one. So let's look in a little bit into Socket.io. So what's so cool about it? Well, out of the box, you get your server and client-side implementation. So I'll show you some code to see what this actually means in a few seconds. It also falls back to long polling when necessary. So if you are unfortunate enough to have to support IE9 into your development, Socket.io will take care of falling back to other solutions if it's not supported in the browser. Also, it adds a lot of features like heartbeats, timeouts, disconnection support, which is not necessarily provided in the WebSocket API. And also, it supports the sending and receiving JSON objects out of the box. So you don't have to bother with the stringifying of your JSON objects and then parsing it back. And the most cool thing about it is that it's very easy to use. So here's a full example. So this is the client side for my Socket.io application, which is, in this case, a very basic chat client. Like I said, chat clients are the hello world of WebSockets. So let's go quickly through that code line by line. So I have my body, so it's an HTML page. I have a text field, which is a text input. I have a button, and I give it an ID. And then I have a big message box, which is a text area. After that, I include this socket.io/socket.io.js file, which is automatically created when you include the socket.io on the server, on the node server, which I'll show you in a second. And then we add our code. So I just create a new socket here, and then whenever a user clicks on the send message button, then I do a socket emit, and I emit an event, which is message from client. And I pass it a JSON object, which has a text property. And it's essentially whatever there's in the text field there. And then I ask my socket to also listen for an event. So I ask it to listen to the message from server event. And it receives data, takes that data, and it appends it to the text area. And that's all you need on the client side for a chat client. So there's a way to send the messages, and then we do something like we receive a message. Now, if we look at the server-side implementation, in here I just use Express as the server. And we just start the server, we listen on port 888, and we start it, and we serve static files. Essentially, that's all we do for our web server. The socket part of it, which is the part that we're interested in, is right here. So in here, I require socket.io, and I pass it a server instance that I'm be using, and that will take care of creating that file that we've seen here, which is socket.io/socket.io.js. Then whenever there's a connection, I can get the socket, and I have one event here. So whenever there's a message from client event that is triggered, so whenever there's a client that sends a message to the server, and this name could be anything. I've chose those, but it could have been food instead. So whenever there's data that comes from the client, I just take that data and then broadcast it to all of the connected sockets into the message from server event. And that's all you need. In this case, whenever there's a message that comes in, I just broadcast it to everybody that is connected. So that's all there is to it, really, into WebSockets. It's a little bit complicated, so or it's a little bit abstract. So what I'd like to do is to go through some actual demos, as well as through some code. And hopefully this will help you to understand how it actually works. So I'll just open my code here. If you'll bear with me for a second. So I have a few first demo here. And if I look at my client here, and we'll just look at the JavaScript part of it, the HTML is not very relevant for now. So what it does here for this first demo is that I declare my socket the way I did it in the slides that I just showed you. And I'm assuming that you can all see my screen still, right? So I declare my socket here. I have a count that I keep locally on this client. And then whenever the user clicks on the send something button, I will just emit the actual count that I have right here. So now I'd like to invite everyone to participate into this demo. So if you go to WebSockets with an S, JavaScript everything.com. You should see the 4 demos that I will go through in the next few seconds. So let's go to demo 1. And it's on Heroku, so it takes a second to get loaded. Okay, so here I have my my client, which just connected to the server. And if you look at the network window, if I refresh it, you will see that it fetches socket.io, and it has a WebSocket that is open. But you will never see any more data that goes through the traffic through the network window, because all of the traffic goes through this WebSocket only. So it's not using any more connections, so you won't see HTTP requests anymore. So what happens here if I poke the server? All right, well, I see absolutely nothing, which is kind of expected based on the code. And as you can see, there's no more network connections that are created. Now, if I take a look at the server code, what I do here is that whenever I receive the event from the client, I just console log the data that was sent from the client. So if I look at my logs, like I said, I'm using Heroku for this demo. So I'll look at my logs, and you'll notice that if I poke the server by clicking on this button, I see this data that I'm sending. And I see that somebody else just connected and just poked the server once and twice. There you go. So you have it, 1, 2. If I do it another time, you should see a 13 appear. There you go. So whenever somebody clicks on it, it sends the data. So it sends the count that is local, sends that to the server. So yay, we can send data to the server, which is completely useless. I will agree, because we could have done that with REST as well. So let's try to use the real power of WebSockets and try to have something that is bidirectional now. So I'll just close this one. So for my second demo, I do the same thing. So I send my count that is stored locally on my client. But I also listen for an event, which is the server count updated event, which I've created in my node script. And that just, it just listens for this event, and it will update one field, or the text in one of the fields on my page. I'll just open the second demo for now. Now, if I look at my JavaScript code in here, you can see that I do the same thing as I used to do. So whenever there's an event that is triggered by the client, I just log that event. But what I also do is that I have a variable on the server now, which counts all the clicks that I have been done. And whenever there's a click from the client, then I just increment this server count, and I trigger an event, which is called server count updated, and I just send the actual count to all the connected clients. So what does this look like? So right now, if I click on the poke server, I have this server count that is updated. Now, if somebody else was to connect to the demo 2, I'm going to WebSockets, JavaScript, everything, demo 2. and we click on that server, as you can see, all the clients that are connected are now being updated, and they're updated in real time. I'll just wait for a second. Oh, and there we go. So as you can see, it's actually incrementing right now, so there's somebody else connected. That's very good for my ego. I know that people are actually listening in, so that's great. Thank you very much. So if somebody else starts poking the server, he will actually increment this, all of my web pages, as you can see right now. So that's great. All right, there's probably a few people connected because it's actually going up fast. So that's great. Cool. All right, so we have a second demo that is working. That's great. We're happy with that. So we can start to see different ways to use those WebSockets now. We can see that information gets pushed to all the clients, and you can see how fast it gets pushed as well. So as soon as I hit this button, you see it updated on all of the clients almost immediately. And you can probably see it if you're clicking on it on your own browser. You can probably see this live feed getting updated, and the delay that you might see is probably more related to the actual feed delay more than the actual WebSocket. Okay. So we've got another fairly easy demo. That's great, but it's fairly useless. It doesn't really give us a sense of how we can actually use those applications or those WebSockets. Sorry. So as I mentioned earlier, the chat clients are the hello world of WebSockets. So what I'll do now, and I will share this code if you're interested. I will share it afterwards so you can actually take a look and see how it's used. So in this specific demo, I've built a chat client. So a full chat client. So essentially what we do here is that whenever, and I've used jQuery just for sake of clarity. So whenever the document, everything is loaded, I just prompt the user for their nickname. And then there's a lot of bells and whistles. But the important part is here. So whenever the user clicks on the send chat line button, we just emit to the socket, and we emit to this event, so new chat line from client, and we send a message and we send the nickname of the connected user. And now we also listen for the new chat line from server event. And whenever there's data that is received, we will simply append that to a table that is on the web page. Everything else is just formatting and fancy stuff. You will notice that here in my data that I'm sending from the client, I have message and nickname. But in the data that I receive from the server, I also have a timestamp property. That's because in this specific example, I've decided to modify the data that comes in from the clients in order to show you a little bit more complex example. So this one is very similar to the one that we've just seen. So essentially, I just listen to an event, so a new chat line from client. I receive some data, but I will transform that data by adding a timestamp property to the data. So I did data.timestamp, I pick up the current time. And then I just emit a new chat line from server, and I emit this new modified and transformed data object. So this is what gets picked up by the clients in here, and that's why we actually have access to a timestamp property here. All right, so let's give it a try. I'll open up my, oops. This is my incognito window, so we'll call him Mr. X. And this is my main window, so I'll just use my name. And now if you want to connect to it, so there you go, you have it. So we now have a web live chat client. As you can see, I can send message and it gets sent to all the clients almost right away. And that's it. So we now have a full chat client. we go. They all get updated. So you essentially have a new Slack clone, if you will. Obviously, it misses a few things. We could use presence detections and chat rooms and a bunch of different things. And there's not a lot of security. So obviously, whenever I broadcast something, it gets broadcasted to everyone right here. But you get the gist of it, So you have a basic chat client that is actually usable. Right, so that's it for my third example. So I'll move on to the fourth example. And this one is meant to show how fast the information can actually be sent using the WebSockets. So a good way to look at those is by using Twitter. So when there's something trending on Twitter, you know how fast information goes, and everybody starts tweeting about it. And I haven't even looked it up this morning, but I'm pretty sure that Pokemon Go is one of the trending keywords right now today, because it was released a few days ago, and it seems like everybody's talking about. So I'll try to track that specific keyword. So what I'm doing here is that I'm using the Twit node module, which is used to listen to the stream API that is available from Twitter. So whenever there's a tweet that matches whatever keyword that we're actually tracking, it will trigger an event on that stream, and I'll be able to do something based on it. So I've changed that. I've changed that code a little bit. So now, yes, so I'm tracking here. And what I do here is that whenever I have my connection, oh, and I have a second thing as well, where I wanted to demonstrate the long processes. So I'll show that in the demo in a second. I'll come back to that. But essentially what I do here is that whenever I get a tweet that comes in my stream, I'm using the Twit. So whenever there's something that matches Pokemon Go, I will actually get that data and emit it to all the connected devices or connected clients. So if we look at the actual code, I have a tweet event that I'm actually listening for. I have some data, and all I do here is that I simply append the data to the page. So this process is mostly only only data that comes in from the server. Thank you very much, whoever that was. So okay, let's look at demo 4 now. And as you can see, it is a trending keyword right now. So you can see how fast the data actually is coming in. And I'll just close this one and I'll use this window instead. All right. So you can see how fast the information is coming in. And you see here that I am downloading some stuff, but it's only the images. So I do have the link as part of my tweets that I get. So I get the link, right? So I still have to download the image. But you see that there's no traffic apart from whatever is going on this WebSocket that is in my network window right now. So all is done through the use of this specific connection, which has only been established once, and then it just keeps on getting the information from the server. And you can see how fast it's actually going. So it's not lagging or anything. And interestingly enough, Twitter is not using such a stream, probably for usability reasons. I mean, it's really hard to read them. But yeah, so we can get the information, like I said, really, really fast. So that's a great way to actually show how it's working. All right, so that was my last demo. Yep, so that was my last demo. So I'll just switch back to my PowerPoint just for the sake of going to my PowerPoint. But as you might suspect, my last slide is Thank you very much for attending. So you do have my Twitter account here. So if you have any questions or if you want to follow me, I will share the information on my Twitter account in a few seconds, at least for the slides, as well as the code examples. You also have my GitHub link if you want to take a look. The code is there, but you'll have to navigate through one of my repositories. And I believe we still have about 20 minutes available for questions. So I'll hand it over to Fernando. If you want to go through some of the questions, if there are any. Thank you very much.
Joel, you did an amazing job. I appreciate it. Everything came out really nice. I also tried out the server. I poked it once. It was pretty cool to see it actually live update. As for question, I think everybody understood it very well down. I mean, it was very well thought out and explained. So yeah, man, congratulations. To everyone else, as always, if this is your first time watching it, just feel free to refresh the page, and you can just always rewatch this video so you can go back over it anytime you like. Joel, is there any final comments you would like to add?
Well, thank you very much for letting me do this presentation. I really enjoyed this experience, and hopefully we will be able to be in touch again. Thank you very much.
Sounds good. Ladies and gentlemen, thank you very much. Again, a big thank you to Joel. I know it's pretty early for him. And to everyone else, cheers and have an awesome day. Cheers.
Thank you.